Good morning. Welcome to the last day of AusCERT2016. We have 3 presentations this morning, each 40 minutes long. If there's times for questions, we'll just throw them to the floor. Our first presenter this morning is Neal Wise. Neal is the director at Assurance in Melbourne. His presentation is titled Threat Modelling in Higher Education. Please welcome Neal to the stage.
Hello. I'm not sure how everybody's feeling today. I'm pretty nervous, so here we go. I'm Neal. I've presented at AusCERT a bunch of times over the years, mainly on wireless and mobility and infrastructure stuff. I work as a security tester, basically, and a lot of the work that we do is around higher education. Let me make a quick adjustment to something here so I can read my notes. Okay. Okay. Be really helpful if this would move right. Okay. Okay. Anybody ever go out in the war driving with us at AusCERT? Like for many years we ran a wireless audit tutorial, and AusCERT got a coach for us 1 year, and then after that it just became a thing that we always incorporated into our wireless testing, our wireless training here, just because it was a lot of fun to spend the day learning about hacking wireless and then go out and not hack people, but get to do a bit of field research. Okay, so what we're going to go over today is I'm going to quickly cover sort of differences between the way I see it as an attacker and someone who looks at enterprises and higher education networks as targets. I want to sort of go through a bit of the what I see as the commonality and the differences in the networks as well. So we'll go on to this first. This is a pretty poor representation of a typical enterprise network. We have the usual kind of DMZ type scenario that we might deliver public service out of. This is very classic enterprise network, no SaaS, cloud sort of stuff, no mobility, no BYOD, no. But basically we have a number of key services that we leverage in order to provide remote access to the network, to support controls at the gateway, and we may have some controls at other parts of the network. I think I'm being a little generous, like for a lot of enterprises, putting it into the routing and switching in the middle, but many do. And then certainly endpoint security. We have multiple locations that we have to operate in. When we go to actually, push traffic around networks, we cross over different zones of the network that we would probably associate with different levels of privilege or trust. So things come in from the big bad internet and then into our DMZ, and that's such-ish. And then we have communication within our internal networks and into the DMZ and out to the internet as well for all our internal clients and internal services. So in reality, it's certainly a lot more like when we have a highly redundant like multi-site deployments for enterprise. Having this kind of scenario where we have traffic that passes through our environments in these sort of ways. And it's generally reinforced by the network. The clients in enterprise networks are generally managed client. They're under the management of the organization. So good or bad, whatever state they are, is something that there's some opportunity to consistently apply and control. But in higher education, a large number of the clients in the network are those that belong to students, that belong to other people who that's just people's personal devices, and so they've been higher education's been doing BYOD like long before that was a big push in mobility. So the other thing about, and this is something for me that I find a lot of fun with higher education networks, and I know there's a number of people in the room who work in, and see some of you specifically in security in higher education, but I know that there's a number of people who work in networking in higher education. The thing that's fun for me is the size of the networks and the capacity of the networks. That when you have clients who have 200,000 public addresses because they have a huge number of Class Bs, or they have 20 gig gateways and 40 gig network cores. Like that's pretty amazing stuff, and it's the kind of in enterprises you don't tend to see that either because problems are broken down because of the distribution of people and services, or when people need that kind of capacity, especially facing the internet, it's hosted generally, and they're probably some kind of internet-based business that needs to have that capacity directly into their environments. It's something that for us is interesting and fun, but it's part of the giant challenge for people who work in trying to manage and control these networks. So if we look at controls on these sort of environments, and this is a really simplified view of things, and in fact, it's mostly not the sort of scale and clustering and type redundancy that you would have in higher education, but it's really just sort of make a couple of points. So similar to what we have in enterprise networks, we have traffic that comes in from the internet. We have a couple of different control points that I'll talk about a little bit later as well, but there's generally some kind of a border inspection and control environment that's usually some combination of access control lists on routers and border firewall systems that are usually configured in ways that we don't sort of run them in the enterprise. They tend to be focused on that part of the environment, on blocking certain types of traffic and maintaining like blacklists against remote traffic. Basically, it's a noise filter for the internet. While, especially these days, and this is probably more of the modern representation of a lot of university services, that there's a data center that's very much like any other enterprise data center. I've kind of represented it here as this sort of tiered model, but the reality is that firewall sits on the side of that, and all those are spokes off of that firewall. And that's how these different parts of these applications would communicate. But so when people connect to services at a university or from the internet, they traverse this first control layer, and the more robust controls really tend to be around these days around these other data center firewall implementations. And we see a lot of different networks. There's so many different ways that networks are organized in universities, and I'm kind of coming up with a bit of an average of everything that we see. But one of the other challenges, and this is probably going toward the way the networks were more traditionally, is that there still are a huge number of services that run out of the private networks, out of the faculty networks that sit within what I always refer to as the general internal network. But it tends to be segmented networks, not so much segregated, but there's third parties like affiliates that are connected to the university. Certainly, certain faculties within the university will run their own services, and going further back in history, ran a lot more of their own services. So there's generally been a push to try to centralize, especially commodity services, into the central IT functions of the university in order to permit consistent application of controls, permit consistent inspection, and it's generally not necessarily what the Department of Engineering does, is to run a mail server. So, but it's for us, it's interesting because we get to see the sort of turf wars of this history play out, because there's a lot of holdouts and there's a lot of exceptions in the networks, that there's a lot of, everything must be done this way, except for those guys who get to do whatever they want. So there's a lot of that, and it's which is really being a little mean, but as an attacker, I don't care about the politics of that. I don't care about how any of those decisions are made. I just see easy targets. So that's something that, for me, that we look at it differently than that. So for us, one of the concerns is that there's large parts of the general networks, and there's huge efforts in a lot of the organizations that we work with to reorganize the internal networks, to introduce segmentation, trying to find ways to identify all the information assets and do classification and make control decisions based on that. So it's interesting for us to get to see progress in that, because we'll usually have a first exercise with someone and just loot the entire place, and then it turns into later this process of building and building and building things. So it's something that for us is interesting. Now, I will talk a bit about these little yellow lines here in a little bit, but I think I should probably just keep moving on. Yeah, there's other networks as well that, let's see, did I just, no, I didn't, okay. There is this out-of-band management networks, which are networks. In some cases, they have, say, subnets that aren't routed, but they're widely distributed as a layer 2 network or within a location. What it tends to be is you have a lot of infrastructure that will be connected on management ports on devices connected to this network. As an attacker, what we try to do is breach one of those devices and then just traverse your out-of-band network, because it's a network. Where we see devices haven't had defensive access lists put in to prevent other devices on the same management network from being able to reach it, then we can have the potential of getting to management interfaces and may be able to brute force things or luck into a default or something like that at that point. But it's something that is a challenge for us. There is a lot of use of host-based controls, like where network controls aren't practical or just for defense in depth. We do see a lot of host-based controls, but they tend to be obviously technology specific, so in one team or another, and they're pretty static because they're just generally, like in the case of Unix systems, they would just be generally a text description of host to trust for different things. So those tied into configuration management, tied into sort of smart management of those hosts will allow you to distribute and create a kind of distributed local firewall for those systems. But we see a lot of that, sometimes when we are actually looking at the configuration for it, we can, as an attacker, if we get onto a system through some other means, we use that to find other things because it says what systems are important and what systems should be trusted, and it may tell us where we need to be in the network. So I guess data assets, like in higher education, there are, in that previous drawing, buried down in here in these in the corner, it's going to make me do this again. That's what I get for animating stuff. Okay. So within different pockets of the network, if we're not talking about necessarily general technology data, but the enterprise data, the business data of the entity, just like any enterprise, there is this sort of common sort of configuration data for the environment, but where we're looking at a university, there's a number of key applications that we will typically see in a university as their kind of enterprise applications, and nearly every institution in the world who's an educational institution has these kind of common core systems. The systems have this magic integration, which I'm kind of being flip here with drawing this stupid star, but it's something that I guess probably looks a little more. We'll get into it actually in just a second. So I'm just going to point at Darren here, taking a picture. So. One thing about these as well is that these are all huge solutions. They're all multi-tiered solutions. They all have dev prod and test instances and even more. So every one of these probably represents 2 to 3 to 4 to 5 to 6, 7 environments for these that in turn all are contain layers of tiered application components for the most part. There's some that flatten the tiers. But so that's a lot of infrastructure to support that, and sitting under a lot of that, of course, these days is a lot of virtualization, and the issues of protecting access to that become pretty key for it as well. So just like any enterprise, security activities in higher education, there's audit and risk functions, there's security operations engineering. We always talk about the inverted threat model because of the resident threat, because there's literally people living on campus, and who hacked at uni? All right, maybe it's just me. All right, I see some nods. So so it's something that there's a lot of time. If you have a lot of time in your hands, and if I had access to to 20 gigs of transit at uni, I would not have finished uni. I know that. So, yeah. So there's also other challenges, of course, to manage. There is a big push, like in any industry, to leverage the changes in technology. So, like software as a service is certainly an attractive thing for higher education. There's certain commodity type applications like student staff email that has migrated, and with that comes integration with identity at the institution and managing the controls around that. I guess the same applies too with a lot of other enterprise applications. Like we've seen a lot of HR applications shift. There's been sort of cloud learning management systems for quite a while. But it's interesting times for this as well, because we're taking a somewhat porous network and we're extending trust and controls from it into someone else's somewhat porous network. And as a guy who's professionally paranoid, it makes me really nervous. So to me, I sort of look at it as a lot like this. And I'll tell a story in a little bit about multi-tenanted SaaS solutions in higher education. So actually looking into the threats in these, like I'm going to quickly go through this just because I want to probably move on to the other parts of my talk. But this is something I don't do near enough. I rely a lot on what I refer to as like a hacker's intuition or something like that. And it's just experience. You know, when you're working with something and it just seems junky and bad and you find out you're right, it's that, and it's just experience with that. So, but that can't be your only guide. And having a consistent, repeatable approach to determining threats or anything is obviously important. So, for me, this is my learning exercise right now, is to try to take advantage of logical processes rather than just going and smashing the shiny objects. So. So I guess moving into this, I wanted to show you just a simple iterative model for this. And this is, like, Microsoft has done a lot of work in this space, and I think it shows. When I started in pen testing, it was like 2000, 2001, 2002, and everything that we did was about exploiting like weaknesses generally in Windows 2000. And it was just easy. And the Securing Windows Initiative and a whole bunch of other Microsoft programs really drastically improved their security. Like they no longer became the top vulnerabilities for the year award winner, and that was I think due to a lot of this kind of approach of looking at their technology. So if now I'm talking about a whole university or a whole higher education network, multiple campuses potentially and all this. To do threat modeling of that, you would really have to break down. You'd start out just at a high level with each of these major systems like the ones I've just mentioned, and you would eventually work through to the actual detail of it. So it would be a large program in itself, but commonly this is used as well when you're designing new solutions, and you can do this sort of assessment kind of on paper in order to decide if the decisions you're making are actually sensible from the point of view of how it would be viewed by a score-based system that allows you to kind of quantify threats and then exposures and the risk associated with all that. So I guess with this one, the security objectives, like say if we take something like, I mentioned a cloud HR solution, take something like that, security objectives for the solution. Would there be expectations that user identity is appropriately protected? Would the application, does it have financial dimensions to it? Does it have to have some certain sort of availability? So there's all those sort of considerations that are just completely outside of security, but it's all part of the whole CIA confidentiality, integrity, and availability triad as well. So so weighing that up. Then sort of digging into, from the point of view of the application, what's important about the application that we would need to actually consider it from the point of view of being attacked. Are we hosting it? Is somebody else hosting it? Who's responsible for managing it? Who's going to maintain that? So it's sort of answering questions like that and then going actually into their next step in their process, like decomposing the application. So there's a very involved process that you'd undertake in order to actually work through the different components of your application and decide what, I guess, how they would mean to you from the point of view of how they could be potentially threatened by an attacker. Then moving on to this identify threats, and then actually looking at it and identify vulnerabilities. Some more old Microsoft stuff, like they have a new initiative that I'm only a little bit familiar with. I was actually, I'm going to sort of mention just smart friends of mine. A gentleman named Matt Jones, who works for Eltham. He's a big threat modeler, and he introduced me to the Microsoft SDL, which is their new one. Through a presentation that I'd seen with him and in discussions with him, and I wanted to just stick with an iterative model just because it's something that I think is familiar for, especially for Australia, because like AusCERT2016, this kind of concept, it's common sense from the point of view, because that's the other thing I didn't mention about this, that this is something that you could do ongoing and keep feeding back into this process as well. It's not just something you necessarily do at commissioning. You could do it as part of operational activities and that as well. But that's Microsoft's models really are around building software and software solutions, because that's what they do. So, but there's no reason why you can't bend these to your own sort of needs and stuff. So they had a couple other things that you use to actually to take threats that you've identified and to sort of assign them to categories effectively, or you identify threats under these categories in order to produce the scoring for STRIDE, for example. So usually the way these sort of things work is that you have like for example, the bottom one, you have a number between, I think, either 0 and 5 or 1 and 5 for each of the categories for DREAD, which is damage, reproducibility, exploitability, affected user discoverability. And then you divide it by the number of those assignments that you made. So so it's all you get this sort of scoring thing. And we a number of years ago were trying to do something similar with controls, and we ended up making up this thing that looked like a Dungeons and Dragons character sheet, because we were sort of strength, dexterity, wisdom. Like it seemed to sort of work somehow in some nerdy way for firewalls. I don't know, so I think for me, like there's accepted methods and ways that are consistent and ways that other people would think are reasonable, rather than me handing them a character sheet from Dungeons and Dragons. So it's something that I think what I'm sort of getting at is that for any of these sort of things, like we want to evaluate a solution well enough to be able to identify the threats to its data or its operation, to identify the exposures that may lead to those and what the risk of that means to our organization. So it's all of these things are just about that. So even moving on to stuff like, I would never really want to use CVSS to calculate threats, just because like everybody I know who uses CVSS, we use calculators to do it, just because anything that requires you to use, I'm trying to remember the name of the library in LaTeX, but it's the one that basically gives you all of the crazy math shit. So that's anything needs that. I probably don't want to be using and for something where I want to get sort of direct answers in that. But it's good certainly good for identified vulnerabilities. That's what we use it for. And you can kind of use it for conceptual ones, but the same idea goes too with 40/60. It's not what it's for, but risk management is part of that process, and you should be factoring all these things in together. There's probably a way to tie your iterative model into another iterative model. So it's another thing that was new to me as well, and I was talking to a friend about this talk that I was going to do, which is Graham Bell, who presented here last year. And he mentioned to me this Mitre attack model and framework, which is this really kind of creepy cyber thing. Like it's neat, but it's to me. So what it does, and this is probably more of what really I'm doing when we're doing testing, is I'm kind of adding up the exposures that I know are likely to exist, because something I should have mentioned about when I showed you that ring with the silly star of all those applications, in each one of those categories, there's 3 or 4 or 5 applications that are all kind of similar, but not, but they solve similar problems differently. But when we go to work with a new client, when we go through each of those sort of categories and we work out, are you using this system for HR, are you using this system for records management and so on, then we have a good idea of where our starting points are just because of the hacker's intuition and experience. But this actually maps out I guess the actual attack steps that we would normally take in order to, if our goal was to exfiltrate data, which it usually in some form or another is, not necessarily as the way that this one is sort of set up. So this was developed by Mitre. It was based on a research paper from Lockheed Martin, and I kind of refer to this thing as kind of drinking the cyber like pretty bad here, because this was the name of the paper. You know, intrusion kill chains. Like, I feel like I'm in, you ever see the sort of weird advertising in the airport in Canberra? Like, I don't live in Canberra, and like you fly in, and it's always like companies that you would never think would pay for advertising to like buy a submarine, you know. They're advertising that for like one person, I think, you know, like, hey, but, it's not my world. The concept of it is really awesome from the point of what we do. The creepy titled paper is really good. I think it's just academic, you know, descriptive paper title meets, you know, cyber kill chain stuff. So, I guess what this leads to me is and this is what the paper that we have that I have to tell you is has been delayed a little bit. So I'm sorry for that. But it's basically it's on common exposures that we do see, and this is the sort of stuff that we would take advantage of as an attacker on our client's behalf. But certainly we see evidence and often find intrusions while we're testing, because we'll find an exposure and like there needs to be a name for the feeling of you found something that's interesting and then you found that somebody else found it before you anyway, so I guess the biggest thing that we have is the fact that the approach to network controls is the approach to network controls is something that is a great enabler of this. That scenario we have this sort of filtering border with stronger controls internally. It makes that network in between a relatively untrusted network. And it's generally treated that way, too, by the institutions as well. That's why they have the data center networks. But there's still important things in that network. It's something that, you know, is... there's also just all of the third-party systems, the faculty systems, all of those that aren't necessarily going to have the rigor that some of the central services may, you know, hopefully have in the environment. So it's something that we would want to, you know, as an attacker, we take advantage of this. The other thing we take advantage of as well is, in many cases, all the way down through the layers, egress controls aren't present. And then we also have situations where we have what I refer to as control disparity between different parts of the network. So if we go back to our network diagram, so this is, again, my typical university network here. So places that we would see controls in the environment, I'm generally talking about network controls, because there's controls everywhere, but I'm generally talking about just keeping me out, like in the first place, for something that's a network-based or physical or any of these sort of attacks as well. We have controls, certainly in that border environment. VPNs enforce controls by like profile type policies and that on users. They tend to be kind of a trombone connection off of firewalls anyway, or like out as a separate leg and coming back into hopefully another firewall filter zone, and then coming back out to the network. And then we see controls going in through this data center environment. But we see sometimes some in all of these, like the branch campuses around, there might be endpoint controls. There usually are. For the managed systems there are, but like HIPS, HIDS type stuff and that. But there's a huge number of internal users that aren't under the organization's management. Some institutions are very good about separating those two groups of users. Some mingle them all together. And that can be, that can lead to issues as well. But there are risk decisions that you can make around all this based on the services that are available to these users. So one thing that always troubles me is there's almost always a replica of Active Directory out in the sort of general networks, just because the staff systems need to interact with Microsoft services, like directory services off of that system, versus students, like, we're probably accessing services that may indirectly eventually authenticate off of that. So they're not necessarily connecting to those systems directly. So, but file services also complicate some of that as well. So there's some of those things that that come to play there. But I failed to mention here too again, I put the red arrow here on the ingress, and it's just that block sum pass everything else. There's some just crazy stuff that we see past that should be blocked, and it's just generally not. And I understand why. Giant network on the other side of it. You make this change, and it's great for 99% of the people, but it stops this critical function in that. So just like enterprises, there's internally a reluctance to potentially apply those controls. But unlike enterprises, the front door is pretty open into these networks, and there's plenty of unmanaged things down in the general networks in the faculties and all the places like that are great staging places for attackers. The other thing that we've seen a lot of as well is that it depends on the approach taken with this environment, where certain systems are in place, like certain load balancer technologies. I see a lot of clustering and load balancing and not any packet filtering. So we have these layers of things, and they're all communicate, and they even use those devices as gateways. But if you can breach a device inside of one of those layers, you can generally connect to all the other layers as well, because they're all routed, and that device sitting in front of it is a nice gateway for it. It's something that egress control in networks is not often present. Since I mentioned before too about the number of public addresses in use, like, that's another big initiative in a lot of our clients, is to renumber into private addresses for systems don't really need to be directly internet accessible. But a big driver for them in that also is the fact that going back in history, there just weren't devices capable of maintaining NAT states and things like that for 30,000 clients, although they didn't necessarily have 30,000 clients in that area, but they still had a whole bunch, and the devices to actually potentially provide that function were even smaller and less powerful, and so on. So I can see that history, again, is part of where this comes from. And the other thing, because it is such a giant carrier-grade network, you can't just go and replace something every year. So there's very deliberate planning done around sort of 5-year plans and 10-year plans around just the general concepts of the network, and then what they're going to do in those periods of time. So, but the other part about the effectiveness of controls as well is, we have again this out-of-band management network that we'll come to in a bit. So everything, because of the fact that tying things back to SAML, for example, shibboleth implementation, ADFS implementations of SAML authentication, will mean that we have a single sign-on function effectively in use in a lot of the applications in places in the university. And like any enterprise, the integrity of the directory is pretty critical. So there's a lot of ways that we will directly influence that by attacking LDAP, attacking Active Directory, obviously, and attacking the identity management systems that feed those as well, because that's a common model we have, where there's an identity management system of some sort that feeds, which is usually the traditional authentication function in LDAP, which goes into certain parts of the university that are interesting to us, and then Active Directory, which is more of the I guess in many ways, I won't even say the modern services, but it's a lot more of the user-facing commodity services, but also as well their identity for all of this, the portal sign-on type, single sign-on situations in the university. So I mentioned the Active Directory servers in the general networks, and why I have concerns about this is that there's usually a large distributed Active Directory environment. So there's parts of it that are at each campus. There are parts that sit in certain zones of the environment. There's now a whole lot of consideration of that and how you actually organize your Active Directory. But what we do commonly see is this system out here that sits there. That's generally for, I think, for the managed systems in labs, but also faculty managed systems and so on as well. But you get this sort of transient property of if we, it's Active Directory syncs. So it may be useful for us to, if this is all in the same Active Directory and the directory that's being leveraged internal to the data center is, we may have some opportunity to kind of cascade our own identities into that environment by attacking the less controlled systems that are external to that. So, from the internet, where a bit of that plays out for us is that this is something that's really fun for us to do in these sort of environments. When you have internet-facing applications that require only user identity and no two-factor authentication or other forms of validation in that, then we may have some opportunity to take a single password and guess it across your 50,000 users because we've enumerated that through something else that'll come on in a bit. But where it becomes very useful for us is being able to use that to access either SSL VPNs or XAuth IPsec VPNs. We do tend to need another identity component of the identity for authenticating to IPsec for that, the VPN groups, shared secrets and that. But the students and universities do a very good job of putting that information out there for us on the internet because it'll always be someone's, this is how I did this with VPNC on Linux. And it's like, thank you, now we just have to guess usernames and passwords. But there's easier ways for us to do that in other places. And part of that comes into this as well. 82.1x is really hard. We've had to ask clients for years to take it up. I literally can count the number of my clients who have taken up 82.1x on one of my hands. It's just something that it's other than wireless. Wireless is obviously heavily used, not necessarily well, but it's something that is a challenge because how do you do it in a large network? It's breaking down the problem in that. But where that sort of leads into, in wireless, we are using 82.1x in higher education. And there's a few institutions that will use certificate-based authentication, which is TLS type authentication. So we have each a device has a device or user certificate that's used to present an identity to the network as opposed to a username and password. And because of the exposures that have been happening over the last couple of years for EPEEP, which is authentication, it can use a smart card, but generally I've never seen that implemented. It exists, but it's just a public key for a shared root certificate that in most devices will actually accept over the air, of course, especially Apple, Mac OS, and iOS. And then it's just a username and password again. So we're back to that same issue. But there's the Eduroam service, which I haven't checked, but I'm pretty sure will be on the wireless service here because it's something that everybody would use. And Eduroam's EPEEP based, and it means that we can sit there and sniff traffic, see the outer identities on traffic, and to guess identities for another institution on the other side of the world because we're using the local participant in Eduroam. Now, they can see this. If I connect to, because where our office is, we're near a whole bunch of training colleges and other smaller institutions like that in Lonsdale Street in Melbourne. And we can see 2 or 3 different Eduroams at different points. There's the potential for someone to take advantage of both the exposures in PEEP to attack the identities that are being presented there, but also to use services like this to attack identities. This was considered in the design for Eduroam. They knew that was a potential for that, and it just leaves it up to the institution in some ways to notice suspicious authentication activity. So. Let's see. Also, other directory stuff. I love pulling information out of LDAP. I've just been told I have 2 minutes, so I better actually wrap it up. But yeah, so two-factor authentication is pretty critical for us. There's a lot of management services that are used for device provisioning that we take a lot of advantage of. What I mentioned before about out-of-band networks, it's all still networks. I use these to do what we need to do. I am really going to go through these quick because I'm not going to make the next person late. But yeah, so data secured, at rest, in a sense, on your file services are ours. Like in many ways, we still find a lot of NFS. We have a lot of fun with that. We find a lot of things in unprotected shares that just shouldn't be there, including a lot of enterprise export data that someone's put there temporarily that we've used to then compromise accounts to the password reset system because we have all the user identity information in their HR or student data that's in it. Yeah, and patching and everything is just terrible and that. But one point I really want to make, and then I'll definitely end here, is that there's this it's not even out of sight, out of mind. Like there's just this separation of the research networks at universities and the general networks that means that for such a focus on intellectual property, it's something that I'm just surprised to see it left up to sort of each of these projects because they're all different. They all do sort of different things, and their network tends to sit off. I actually left a firewall there. Off of the first edge of the environment. So it's like me to leave a firewall there. So, but yeah, and the multi-tenanted issue here. There's so many different ways to provide services to that when you host an application, and we've had situations where we found that we could access. We were testing for one institution and achieved some access to the backend database. And we're able to actually look at other data on the database server, and it was another university's information. We actually went to one of our universities to test an on-premise version of the application and confirm that that was that existed in that as well. So it's I don't know, it's interesting. So look, I will skip these quick wins. And look, we'll just go on to the end of this. I really should head over to the next person. So I really appreciate your time. I will get the paper released. It is end of financial year, and we've just sort of hit a crunch. So but thank you very much for listening. And if you have any questions, I'll be around.